السلام عليكم ورحمة الله. أهلا بكم في قناة Computational Design بالعربي، قناتكم المفضلة في تعلم ال Computational Design والكودينج وال AI وكل ما يخص النيو تكنولوجي واستخداماتها وتطبيقاتها في مجال العمارة. النهاردة سعداء جدا بوجودكم معانا وسعداء بوجود ضيف مميز جدا اسمه مايكل ويكرسون. مايكل ويكرسون ضيف مميز جدا لعدة أسباب. مبدئيا هو أستاذ مساعد في قسم النحت في معهد كانساس للفنون، وفي فترة من الفترات كان رئيس قسم النحت في الجامعة، وليه قصة كده مع الكمبيوتيشنال ديزاين والكودينج. لانك هتسأل يعني احنا قناة كمبيوتيشنال ديزاين للاركيتكتس، ايه اللي يخليك تجيب لي ضيف بيتكلم عن النحت؟ الحقيقة يعني بجانب ان النحت والاركيتكتشر هم مش بعاد عن بعض قوي ومرتبطين ببعض نسبيا، لانك لو بتتكلم عن ايكونيك بيلدينجز، لو بتتكلم عن التصميم المعماري، في جانب كبير من التشكيل والنحت في الفورم ميكنج. بس مش ده موضوعنا. موضوعنا مايكل اللي حصل معاه حاجة في سنة 2018. قرر ان هو يبتدي يتعلم كومبيوتيشنال ديزاين. كان عنده خلفية قبل كده لان هو كان بيبني مباني بالخشب وبالميتال كاستنج زي ما هتشوفوا في الانترفيو، ولكن هو قرر يتعلم كومبيوتيشنال ديزاين في سنة 2018 بالتحديد، من 5 سنين. والمفاجأة ان هو كان عنده 51 سنة. حاجة يعني حاجة غريبة بصراحة، يعني حاجة مايند سيت لشخص تتمنى ان هو يفضل، يعني يكون في حياتك ناس كتيرة زيه، يكون في حياتك ناس شايفة انه لا، العلم ملوش مرحلة بيتوقف عندها. الشخص المفروض ان هو بيشتغل وبيتعلم طول حياته، طول ما عنده الصحة وطول ما يقدر. والموضوع المايند سيت دي لو موجودة عند الناس كلها، العالم بالكامل هيتغير، والعالم هنشوف عالم تاني خالص. لو كل الناس بتفكر بالطريقة دي، انا عايش علشان هيبقى عندي ليجاسي، هيبقى عندي حاجة هسيبها للناس، هعلم ناس تانيين، هعمل حاجة. وطول ما انا قادر ان انا اكمل فانا هكمل، مش هقف ومش هاجي عند مرحلة اقول انا كفاية علم لحد كده، او كفاية شغل لحد كده، وافكر في الريتايرمنت بلانز. المهم، بدأ البداية خالص بان هو اخد كورسات في الجراس هوبر والراينو، وبعد كده بعدها على طول بفترة بسيطة هو قرر انه لا، انا مش هشتغل بالسوفت وير بالطريقه التقليديه، بان انا ابتدي اتعلم، بان انا ابتدي اشتغل باليوزر الجرافيكال يوزر انترفيس. لا، الموضوع بالنسبه له كان تحدي لدرجه انا عايز اتعلم البرنامج اصله بيشتغل منين عشان اتملك من البرنامج تماما، زي ما الاستاذ الدكتور خوزيه لويس في هارفارد، في جامعه هارفارد المعروف جدا في مجال الكمبيوتيشنال ديزاين والبروجرامينج، بيقولك الكودينج دايما بيدي الاركيتكت باور اند فريدم، قدرة انك تعمل اي حاجة تتخيلها، قدرة انك تعرف كل امكانيات البرنامج من غير بايسز، من غير البايس اللي انت بتاخده اولا من الشخص اللي بيشرح لك البرنامج، وصولا للبايس بتاع الجرافيكال يوزر انترفيس. لان انت ممكن تبقى شايف ان في طريقة معينة سهلة اعمل بيها فانكشن معينة، ودي الطريقه اللي ظاهره قدامك في السوفت وير، بس لما تبتدي تشتغل وتبتدي تتعلم هتلاقي ان انت كان ممكن تعمل الفانكشن دي بطرق تانية، والطرق دي موجوده بس انت مش شايفها. الكودينج هيخليك تتملك من كل الامكانيات دي. نرجع لمايكل، بدأ يتعلم سي شارب، وبعد ما خلص السي شارب ابتدى يتعلم بايثون. لقى ان بايثون ليها لايبراريز كتيره يقدر يفتح بيها مجالات تانية في مجال الاركيتكتشرال موديلنج. لايبريز زي نمباي اللي بتتعامل مع الماتريسيز وبتتعامل مع اللينير الجبرا، بتتعامل مع كل ما يخص الكمبيوتيشنال الجوريزمز. وتخيل الباور اللي عندك انك بدل ما يبقى الانبوت بتاعك لكومبوننت او لفانكشن هو رقم او 10 ارقام او 20 رقم بطرق الى حد ما محدوده، لا، انت عندك حريه انك تكون ماتريكس من 1000 رقم، من أي رقم يجي في دماغك، وتقدر توصل ده كانبوت في البلجن او في الكومبوننت بتاع جراس هوبر او في السي شارب سكريبت او البايثون سكريبت اللي انت كاتبه. هتلاقي في مجالات كتيره اتفتحت، حتى كمان الداتا فيجواليزيشن. لو بنتكلم على بانداز داتا فريم لايبراري موجودة في بايثون كذلك ابتدى يفكر فيها ويشوف ازاي يقدر يستخدمها ويطور مع نمباي algorithms تخلينا نبتدي نعمل data visualization بشكل سهل. وصل ان هو يبقى accredited بايثون ديفلوبر، وابتدى شركات وناس كتير ومهندسين ومعماريين وديزاينرز يتعاملوا معاه في انحاء العالم، في اوروبا وفي امريكا الشماليه. والشركات بقت بتطلبه ان هو يجي يبتدي يطور بلجنز للابليكيشنز بتاعتها او للسوفت وير اللي بتخص الشغل اليومي بتاعها، عشان يسهل التاسكس وعشان يوتوميت التاسكس بتاعت الشركه بتاعته. فدايما بنسمع عن ان في المكاتب الكبيره عندهم البلجنز الخاصه بيها اللي ما بتطلعش للعلن تحت اي ظرف، ومحدش يعرف البلجنز دي بتعمل ايه، وعمرها ما هتبقى اوبن سورس، والمكتب ده بس هو اللي طورها وهو اللي شغال فيها. ده اللي مايكل بيعمله بالظبط. الشركات بتريكروم مايكل عشان يبتدي يعمل لها بلجنز بالكودينج تسهل عليهم التاسكس اللي هم عايزينها، سواء على سوفت وير زي راينو، زي ريفت، زي بلندر، كل البرامج اللي تتخيلها. وطبعا انت لو اتعلمت كودنج على اي برنامج الموضوع بقى سهل بعد كده انك تطبقه على اي برنامج تاني، لانك خلاص اتعلمت الالجوريثميك واي اوف ثينكينج. مايكل اتعلم في مدرسة في جامعة ووترلو وجامعة يورك في كندا. واحنا النهارده سعداء جدا ان هو معانا عشان ينشر معانا الخبره واللي هو قدر يتعلمه خلال الخمس سنين ويشتغل فيه، وقدر في ظرف وقت يعتبر قليل جدا ان هو يبقى اكسبرت فيه. النهارده باذن الله هيشير معانا النولج بتاعته كمان في الماشين ليرنينج وتطبيقاتها في مجال الموديلنج. احنا سعداء ان انتوا معانا وسعداء بمايكل. هنبتدي الانترفيو على طول. السلام عليكم.
Thank you.
You're muted. Sorry, can you please unmute your mic?
Oh, I did unmute it.
Yeah.
Unmute it again. You were hearing me fine. Should I log on again?
That's perfect. We're really
What's going on?
yeah. We're glad to have you here. We're really happy.
Yeah, I am here and ready. A little anxious, like I said, just working online and remotely. You just hope the internet doesn't give out at any time, but I think we're in good shape. And I know we've scripted a little bit, and I know the beginning parts are quite kind of an introduction, and then I have a lot of information, and I really want to make it to that demo and have that good 5-10 minute demo on numpy. That'd be great.
We're really glad to have you today. Everyone is really excited, and we hope we learned a lot from your experience. Okay.
Now you're
So I give a fast introduction about you to the audience, and now we're going to start our interview. And we're going to start with, as an artist, how do you find sculpting and architecture similar?
okay. Like I said, I've scripted this, and we've lost a few minutes, so I'm going to make sure I hit this. I think it's important to realize that I never focused traditionally on traditional or contemporary sculpture per se, even though I've been a sculptor my whole life. As a child, I found inspiration in family, machines, and everything natural, and I spent most of my time playing out in the woods, like a kid would. But I fell in love with mathematics and physics in high school and during my early years in university. Sculpture came later. The metal foundry, really inspired me, and metal fabrication has always motivated my early forms. Later in life, I acquired land, and this is not my land in this picture, but this was some property that was given to me. And in the span of about 9.5 days, and a chainsaw and a backhoe, I was able to build this bullhorn structure. The one thing about not working on your land is when the land's gone, you lose what you've done. So then I acquired my own land in the next slide, and I began about 2009 building earth ships from adobe, timber, and stone. So you can move forward an image, and I can talk about the next one. As my sculpture installations grew, I found a pressing need to consider obviously more architectural requirements for safety of buildings as I was sculpting, because all of these pieces you're seeing, Hamlet's Mill in 2010, we can go to the next slide. Um, this was actually my first digital work I did in 2010. I was visiting some friends in Holland, and I picked up SketchUp while they were working in Vectorworks, and I did this very simple model of what I kind of inspired to make on my land. And when I did come home, I did do that summer. But they were always sculptures, everything. It became a light tower. This is the fall of 2011, and I just lit it up from internal lights. And that was kind of a marker, a beacon on my land. So I've always thought of pushing myself in very small groups of people or even individually. All of these works you're seeing, landscapes, were done by hand, shovels, wheelbarrows, and just time. And I spent the first few years on my land. This was a Grieve foundry, and so I built this earthwork, this sod kind of house from another type of approach. But like I said, you have to consider those kind of considerations, even though you're on your private land. It became more and more pressing that I thought about safety and what went into these. And I think you can just run through a couple more of those. This was a large wood kiln I built, and that's an interior view of it and an exterior view with Hamlet's Mill behind it. And it was just this long kind of whale-like shape, so I just gave it this kind of novel name. And then there was a photo shoot here in 2013 where a friend came and did all these works of fire over Kansas, and we lit up for this photo shoot, kind of his vision, but me as a backdrop or theater. And my land's always served as a playground for anybody wanting to create anything. Of course, off the grid for the most part. I think those, yeah, those. And then I built this. This is how I remember standing on top. It was I acquired a Sinva press ram, and I just went into the earth and started manufacturing it. Of course, with the skills I'm going to show you today, you'll see that I don't want to build this way anymore on my land physically. I would like to, obviously use additive manufacturing and large-scale printers, and think about this in the future. So we could probably move on. This was just kind of a humorous shot at the end where we brought over the neighbor's donkey, and I incinerated one of my last sculptures I built in town. It functioned kind of as its own cupola wagon, casting its own bells and wheels, and it becomes pretty surreal in what you're ending up doing. And things kind of change in the next few years. Here we go.
Yeah. And how did you first become interested in computational design and coding? What drew you to explore these areas in relation to your artistic practice?
Well, as I mentioned, math and computers came first in my life, and although I was enrolled in pure mathematics at Waterloo University in Ontario, Canada, my coding practice has only been very recent. I left, C++ and Pascal and Maple and all these programs behind in the early 90s, and then I only returned to this because of the advances in these scripting programs in Grasshopper and Rhino 3D. It's important to remember that I'd never even made a 3DM file before I opened Grasshopper, and it simply opened that window to this kind of parametric and then on to computational design. Yeah, I fell back in love with kind of computer coding in 2018. And I have another part of that question. I was encouraged, obviously, at my school because we put in a fab lab, and the campus started to become technically more proficient, and the computers were there, so I had to run an elective class, which I called the Human Hand in Digital Sculpture.
Perfect. And how long did it take you to feel comfortable with coding?
It was almost immediate, and I took one of the most simplest programs out there, which comes with AutoCAD, Tinkercad for children. There's probably MIT uses Scratch, but there was a Tinkercode application for Tinkercad programming, and I couldn't believe the complexities of the trigonometric functions that were in that for kids or for people starting out. So I transitioned into Node scripting, was instantaneous, and I started scripting these overnight, and I realized I could output even random scripts into the Rhino viewport. And that brought me into Rhino very quickly. I was hooked on nodal scripting with mathematics and jumped into Grasshopper and very quickly into anything Python or C Sharp online.
Great. And how do algorithms play a role in your artistic process for generating forms or patterns?
Well, I think algorithmic thinking is key to everything I do now. I believe it's always been there in my life, from very early math assignments to playing role playing games to taking martial arts and writing down katas and moves, learning how to cook, learning the guitar, the bass guitar, and certainly building sculptures and installations. There's something extremely organized about going to the hardware store and seeing your points as seeing your screws and nuts and bolts as points and your lumber as lines and sheets as curves. Most recently, I was more encouraged to teach algorithmic modeling in my electric class. And what that allows people to do is see that they can come computationally to their work, even if they're not even using the computer. They can actually do it very analog. Seeing things in the world computationally grows for a step-by-step process, allows me for a step-by-step process of creation that moves towards a vision that's more dependent on the quality and success of the steps that preceded it. So if I could, I always found when I made sculptures or was doing an iron pour or bronze pour, as long as everything was worked out to a certain level and I can move to the next stage, then that final vision could come to fruition.
That's perfect. In your courses on computational design and coding, what are some of the fundamental programming concepts and principles that you cover?
Well, this course, I'm at an art school. I'm at an undergraduate art school, and I was asked by product design students to really, not send them home to learn the certification level one in Rhino, but cover that. And since they cover that in those tutorials in 6 days, it's 6 half classes, I figured I should be able to introduce students who knew nothing about computers to Rhino within 3 weeks. And then we move on to Grasshopper. And then a lot of them don't really in an art school, jump wholeheartedly in the node scripting and coding and computational design. But it's there for people that wanted to take the class 2 or 3 times. So I kind of stack teach it for different levels of students. But I do want to get Rhino down in that interface almost immediately. A lot of students know Blender. A lot of students have delved into Unity. We really want to make beautiful forms and beautiful objects that can be exported and easily printed or manufactured without depending on new plugins like what is it called, the wrapper function, the plastic wrapper function. I think we're okay. I lost your image for a second.
Yeah.
Oh, I think I continued that onto another part. I think it was the second part of the question.
Yeah,
I'm not sure if you asked it. Yeah. In the course, okay, the second part was computational design and coding. What sort of fundamental programs? If a student shows promise in algorithmic design and nodal scripting, then I will ask them to take the second half of the class, algorithmic modeling or computational design. They can take it as a senior. And at this point, they might focus away from parametric design Grasshopper and realize they need to know Python and they need to know C#. In any case, the coding comes last. However, I'm thinking of teaching right off the bat this fall, showing them how to model from text prompts immediately with either ChatGPT or even GitHub Copilot and Visual Studio to code. It depends where they are. And if you know anything about Grasshopper, the GH Python node is a great place to start. I think the hops node is even more powerful, but I'm always going back and forth between that. And I'm just watching the developments of AI and applications of AI. Not so much doing machine learning with it currently with the students.
So here you can find some of the software and programming languages that Michael was talking about. You want to learn more. And how do you guide the students applying these skills to their artistic projects?
So how do they translate into that? The benefits of developing parametric and computational design are evident in the new forms the students are making. Our budgets have become tighter. We went through, obviously, isolation period in 2020, and maybe what we did traditionally in bronze casting and sand molds and green sand, we were able to work at a very fine kind of manufactured shell casting technique. So they can build their blueprints in different iterations, can be printed from their digital files, and then a single iteration that's chosen can then move into model making, mold making, direct burnout from PLA prints, and we've achieved an incredible level of precision and casting. And the biggest thing is we've actually moved people from the lost wax method of losing your original into something that's much more manufacturable, interchangeable, customizable, and multiples can be made as well. So the models and print designs can save the students a lot of time and money and they can still get around to creating some of those traditional cast sculpture techniques and forms. Hope that makes sense. But I'm still teaching foundry and metalwork for the most part.
So you've experienced a lot with
Okay.
some uh, Python libraries like numpy, which is a fundamental package for scientific computing in Python, and it is very useful when dealing with arrays, matrices, and linear algebra. Have you used it in your computational projects?
Okay, so now we get into my own independent research and development. This is not, whereas I used to do exhibitions and travel and pull off installations that maybe took a year to make and try and do that across the globe a little bit. My research has really come home again and onto my home computers and laptops and working with that. So NumPy became a real passion of mine because as I was developing parametric files, I realized it was all about the number slider. It was all about the gene pool number slider. It was all about gaining numerical control. Anything going to a machine or a tool on whatever access needed that numerical control. So I use NumPy explicitly for managing the numerical arrays in Visual Studio through vectorized operations, which allow me this speed at which to move, which you'll see in a demonstration later, that would slow down your scripts normally in Grasshopper. This allowed for larger data sets to be managed and at the speed of what NumPy does in C and Fortran programming, which is bringing me back to like 1988 and 1992. The hop server is pretty incredible, and I want to cover that a bit today. And the GH remote plugin allows me allows me to output the outputs to be brought into the Grasshopper canvas as organized data trees full of integers, floats, booleans, and even strings. And what I found, and we're getting into this particularness of it, don't make your files heavy with these very quick numerical libraries. There's no reason to go into Rhino 3DM or Rhino Common or even Rhino script syntax. You simply want to output those traditional terminal matrices or multidimensional arrays and then use those to what Grasshopper does very well, which is data trees and understanding data trees. And of course, NumPy moves you into pandas. And if you want a taste of this, just take a look at the most downloaded plugin, which is Lunchbox for Rhino, which allows you to import, export, change over CSV files, Excel documents, SQL documents. But I'm still running into a little bit of problem with pandas, which you're going to ask about, because Grasshopper, of course, is not taking all of these data types. So you have to kind of fudge around and change them as you make your scripts. But with Copilot and GPT-4, if I'm late coming back to coding and somebody's been doing it a little while, you're going to find it very easy. And then I think you said, can I explain the core ideas behind applying those? And this kind of continues. And that was gaining that numerical control. But what traditionally you would move NumPy through pandas into a book that would teach you how to work matplot library, try and imagine matplot library amped up so you can make 3D models and 4D simulations with Grasshopper. So with the assistance of AI programs, I can basically move from that kind of threshold past matplot library and bringing that right into Grasshopper for whatever diagrams I want. You could solve some of those Kaggle competitions possibly with a Grasshopper visualization. And as an artist, obviously, I'm all about data visualization. So anything someone imagines and is able to numerically control will be possible. This includes architecture, engineering, construction, design, visual arts, and even poetry. And this is where it gets very beautiful in my mind that I actually think this is a language, we will find beauty in it, and people will start applying it. So it's not a place not for the arts. I think it really is a place for the arts. You have to have a really abstract imagination about that, but that's the same as goes for physics. I don't think you could ever get into physics without a good imagination. So I see coding as a language, I see coding as an instrument, and anybody can play different, tunes within that. And hopefully have a good programmer's mind's eye. That's a lot of information, and I know you're showing a lot of images here that cross over stable diffusion.
Yeah.
But there's one I wanted to spend a little time on NumPy with a demo. I know we're at 11:36, and I could probably talk about that, but I'm curious as to what the next question would have been before we leave NumPy.
It's about pandas. So if you
Yeah,
want,
yeah, I can go there. I have up on GitHub, and I have a Pandas Python app that's generating, but I really am hitting Well, it's also very tedious and kind of boring to write pandas completely and utterly. Like you want to jump ahead. You want to jump ahead to like, can I input my files now? Can I get it into bigger data sources? But until you know those functions that work and methods that work with pandas, what would you do with that data anyhow? So the biggest trick is making a data frame come out into Grasshopper as a mix of columns and rows, text and imagery, and then at what point, dealing with pandas and data frames in Grasshopper, do you even want to deal with unclean data? Like you just like it would be great to have a script in Grasshopper that shows that your data is messy visually. Like it shows the geometry that's not, it's like a building. You would have a building that doesn't have the windows, doesn't have the doors. It needs that. But I think more importantly, those jobs are still available for people. And that's what I would say with pandas. You feel the urge to go back into uh, uh, um, Jupyter notebooks and do those things quicker and faster and get a simpler model. But if I can get it working really well and keep the ideas simple, you'll see it in my example with NumPy. But I've got all the Grasshopper scripts up and paired to basically learning NumPy. And like I said, pandas, I'm having the same trouble with data frames as I was having with data trees in NumPy. That's pretty specific, but that's where my research is taking me.
This is really perfect. And how do you approach teaching coding to students who may not have prior programming experience?
Oh, absolutely. This is my biggest challenge at my educational institution. Trying to keep a class running with very small numbers. Students don't come to the Midwest to this school traditionally to learn this type of stuff. So I've turned to the internet. And I've done that through working with potential students, developers, and collaborators. I've teamed up with architects at MGSM, friends of yours. I've worked through the American University in Cairo and through Digital Futures. There's several companies and institutions and businesses that kind of approach you for ideas. Once you start to gain that numerical control, and I maintain like over a dozen, even though there's a core half a dozen that work well on Facebook groups that I just feed information to constantly. I never really stop. So I really have a hard time locally, domestically, like regionally pushing it. But if you enter the international realm, you'll always find somebody's out there, maybe a few dozen that are kind of interested in your research, and then you can kind of get into those groups. Um, I think the next question was,
Yeah,
did
it's
you
about
ask that? What
strategies
strategies?
and resources that you find effective in helping the students grasp coding concepts and apply them to their sculpting projects or modeling projects.
Absolutely. So first and foremost, Rhino 3D education. I just had an email from Neela Zaker this morning, and she's been working on a series after Grasshopper and Rhino and Python. Incredible work, but she's done Rhino inside Revit, and of course, I'm pushing myself back into applying all of these kind of creative modes of thinking and programming into something much more practical like architecture. So Neela Zaker at Rhino 3D Education, everything Python through coding with Mosh has been a fellow that I've always went to just to learn the language. And then C Sharp, it's always been parametric camp with Jose Luis Garcia, and that's C Sharp programming. And then Raja Isa, and I should say that right because I just learned how to say her name in Arabic, and it means Raya. I want to remember. It's like health or something really beautiful. But she has white papers in Rhino 3D education on coding and mathematics. And I just checked out your website, and you are spelling out how to do C Sharp for people
Yeah,
to learn that through Grasshopper. So I really got
Raja
to get through
Issa,
your own series.
Raja Issa is an Iraqi architect that works in McNeil. Yeah, she's an Arab.
Absolutely.
Yeah,
And then, yeah, yeah. So those are my top go tos. Um, but I find, and I'll get to it later, individuals that will post daily. Like I'll be encouraged, like to do something ridiculous, like start transforming E to matrices, which I was doing last week. And Timo Harbo Zollner reached out and said, "Of course you're doing something like that." So the encouragement comes live in real time, and I'm usually online half the day, it seems, at least in the summers. You've just got to be there. You have to be able to put the time in, which I will struggle this fall to have as much time as I've had these last 2 months. So my research, if you look at my GitHub, it's definitely like bursts with posts in the summers and winter sessions. I think your next question is kind of a machine learning question. If we have time at the end, I'll show that
please.
demo. Yeah.
Yeah, it's about GH Python and Rhino script. So we want you to advise the people about the difference between C Sharp and GH Python in Grasshopper, which is
Oh, sure.
easier for the architects to automate or to start with if they want to start learning coding.
I learned Python just flat out as a kind of. I went in and I learned that just from learning Python. I didn't even associate it with Grasshopper to start. And then I started to do that with .NET for C Sharp online, but I needed applications. And I absolutely started hard into Grasshopper with parametric AMP with Jose Luis and running through how to learn C, how to apply it, how to do those problems. And um, if it comes closer to what to do with those things, if you're looking at machine learning, download that plugin for Introduction to Lunchbox from Proving Ground and watch that and see how it's applied. I also just go to the library. And so for Python, one-liner books, Python one-liner books is a beautiful small book by O'Reilly Press. And I thought I can use the GH Python remote node to access all of those libraries and just write this book, transcribe it into a Grasshopper doc. And I did that back in maybe 2021. And I don't know why I was doing that, but recently I've come back to GH Python remote. Didn't know at the time, but you could start really fusing the advanced Python libraries, even though it was 2.7 version, with the Rhino Common libraries very smoothly. The other thing, yeah, the GH Python remote I have to talk about, but machine learning was very simple. If you don't know enough how to write the basic scripts of what's popular, you could always use the hops node, which I wanted to show example today with GitHub Copilot, that as long as you have a textbook or an idea to prompt you, and it's been put to press and it's been on GitHub, it will literally write itself for you. And that's what I wanted to share with people today. I do not have a huge, I don't have a call to use it every day at work, but I find with understanding a system of a textbook or a notebook, there's no reason that those apps can't write themselves chapter after chapter like that. And then I am working on a work in process for a GHOP server into machine learning, which will go, it's kind of followed the numpy pandas and directly into machine learning. And that's what I'm working on as well. But I'm starting to get driven off into, I'm starting to get driven a little bit back into Revit to see some applications of this. Oh, and I have examples that are online that deal with K nearest neighbors, machine learning. I have neural networks. That's all coming out of playing with the GH Python remote node and the Python one-liners. So it's kind of hit or miss, like where you want to go. I think Python is obviously the choice that most people would want to do, but I just think if you know how to write C# a bit, writing Python's so much easier. So you can kind of read your script faster as maybe certain programs like AI or Copilot are writing it for you. You can read it faster, right? And with these programs, they write it in whatever language you want back to you. They comment beautifully. You can stay within your most common language.
Yeah, but C Sharp still has, let's say, a ranged way in coding in Rhino Common. Exactly. Yeah.
Yeah. Yeah, I definitely think Rhino Common, you'd want to come back to it. And there is a trick with hops that it's very slow download if you want to use Rhino Common. But there's a beautiful tool, Rhino 3DM, that can be imported very quickly. So as long as you're okay with simple geometries, it doesn't make sense for me to go into Visual Studio Code and output heavy forms. I just want to really control those complicated numerical inputs to your nodes in Grasshopper. Hope that makes sense. Maybe I could show a demo.
Of
I
course.
think the next image was kind of where I wanted to go with it. But let's keep answering questions because there's so many questions.
Yeah. So machine learning has transformed from a knowledge-driven approach to a data-driven approach since the 1990s. Tell us about how you found applying machine learning in computational design useful.
Okay, I got a little lost on my questions and my answers.
Oh,
What number question was that again? I'm just curious.
it's question number 49. No, wait, the slide
That's the
number
slide.
49. Yeah,
That's before Hypar. I just want to get that question in front of me.
yeah.
Oh, so what would you share? Personal projects and art were created by machine learning. Um, Maybe just ask the question again because I've kind of gotten offset.
Yeah.
Oh, it's right here. Machine learning is transformed from the knowledge-driven approach to data-driven Nice. Tell us how you found applying. Well, very simple geometries. And the best thing to do is to see those simple geometries um, within a grasshopper sample. And I think slide 42, I'm not sure if you can show that one. It's pretty, it just deals in iterative qualities. It was an ability to go in and possibly use some data to drive a geometry. I think it's a yellow and an orange, yellow and a pink kind of geometric shape paired next to each other. And it might be the new slide. Let's just try and jump there. We got a little out of order. Keep going forward a bit. Yeah, these are all the slides that you had.
This one?
Keep going a little bit. Well, a little farther because those were done before I got into those libraries. A little farther, not back, but ahead. Yeah. I think you'll see it. It was under a machine. Yeah, this one. And it's not a great slide. It's not coming up too great on my screen. But imagine if you built a geometry like a floor plan. Keep it simpler than these 3D shapes. And you had data that was driving that. And that would then be predictable to your next floor plan or an elevation or a section of a building. You could have enough models to maybe drive that. And my example of using it was to train things. And I used the Spartan helmet as an example, kind of a cheekbone, or thinking about what curve was manufacturing that. If you had enough curves and data collected to build a geometry, couldn't you use that to have a predictive model, even if it's just linear regression model, or if it's k-means clustering, like if it was just a clustering algorithm. So I really see those machine learning algorithms from moving from numerical control into points. And of course, with that, you're back in looking into sorting algorithms because you want to manage what you're putting into the grasshopper window. So I've done the numpy, I've gotten into the pandas, and the machine learning is always bringing me back to how it's applied through Lunchbox. So, but then you get caught up in the applications of those within some of those AI sources. So it's all very current. It's all kind of what I'm playing with. And I think you're posting a few things that I've done online. Yeah. Sorry to get you out of order. Well, I was never doing it so much for building an architecture, but certainly for building shapes. So there are, and I started to mention them, the one-liner playlists that I do on YouTube, because all my videos are open source. They're all been there. There's well over 1,000 of them, but there's a playlist that'll walk you through the one-liners from linear regression examples as a predictive model. Then I'll do some data-driven design kind of applications of the machine learning. And then the neural networks were kind of fun. That was kind of the last stage of what they're trying to push within that. But those visuals are all tied to the Grasshopper scripts, fully parametric, but they're running back in Visual Studio Code. They're running back in these one-liner scripts. So you can change your inputs and make them parametric. And if I show an example, I do want to get to it today, because just because you can write a script over in Visual Studio or GPT-4, you've got to still bring that in somehow through the hops node, which automatically loads from any server, or you can set up a GH node for all those inputs, or a C# node. There's no reason not to use, as long as those languages are accessible to that program. And so, yeah, I used k-nearest neighbors in one example, and then I kept going and playing with this neural network analysis. And that's what I had. And I think there's like 5 or 6 examples on there. And I don't give tutorials. I just show overviews of what I've done, and then I give the files to people. Like get it working and play with it. That's really where I like to go with it.
Yes, that's really helping. Yeah,
but I need focus. Like I don't, as a visual arts student in sculpture, need to do too many neural networks. But it's like other people are interested in those creative ways in. It's kind of like I don't have a definition. Math is never approached that way. We talked yesterday about that. I'm not starting with a definition. I'm absolutely being curious. I'm finding some general things it can do. I specialize, and then maybe I'm like, hey, that really would help for that model. And then it comes out in the end. And that's kind of how I hit it. And without so much an employer putting me towards this, or a peer group, I've done a little bit of development with a couple of others. I'm just left kind of grasping and playing, and you end up getting to all these cool ideas. And I think I've just kind of spontaneously become something on the internet to just like let yourself loose. I was asked today, a fellow was like, I'm 50. How old are you? Because how like I feel the pressure in my, and he's got a wonderful job, like high up in an architecture firm. He says, I just don't feel like, I feel like I should leave that type of creativity for the younger He's actually said this. And I said, listen, I started late, but I'm curious. And I think you have to do it you have to have a place in your employer that has innovation where you don't have to show profit and you can get in here and you can play around with. And so that's why I tend towards these companies that have an innovation kind of team that's together and maybe has a percentage that they can explore ideas. So that I kind of volunteer a lot at companies and places and educational institutes because I get to play.
That's right. And automating Grasshopper with Python and Hops is the name of one of your courses. What is Hops and how do most automation pipelines work?
Well, since we have about 10 minutes left in the scheduled time, why don't I just show it? I mean, it's gotten pretty abstract here. I'm not sure if people are following me. Let me grab, I have it all set up. I'm going to go off script now. We may come back onto it, but let me share screen and make
Okay.
sure I'm sharing the right screen. I want to share a window that is, I want to share an entire screen of this. So this is not what people are used to when they open Rhino. So everybody can see this, the little
Yeah.
Rhino environment down in the bottom right.
Just give me a second to edit.
Yeah. And I'll just take it off. So hopefully I can do this on my monitor up here. No, I can do it down here. Um, so this is where the whole lecture I think is moving towards. Am I sharing it?
Yeah, your screen is done.
Visual Studio? Okay. So if this is alien to you, you're like, okay, I like looking at Rhino. Well, I very rarely need to look in Rhino because I'm not building those models. I'm trying to get to a numerical control. And so what I have 6 of these files I've written in GH Python. And sorry, in they are GH hops nodes. They're written in Grasshopper. They are basically how to learn NumPy through Grasshopper. Everything is up and running. And you see these nodes and you're like, how do I use NumPy to write complex numbers? And I just this was not actually using NumPy to start. I went into the NumPy arrays, and these nodes have this little hops logo in the bottom. You have to download the plugin. You can take off this viewport, and you'll see it's just a hops node. It looks identical to bringing this in. However, whenever you have a hops node from your plugin, you can grab a URL from any running script, any application, anywhere on the cloud. So this is going to get good. I'm going to go 10 minutes, and this is why you're here, I think. So this script is running this IP address, and it has a call name to a function array1d, which is basically learning NumPy. And what's happening over here is this script you're looking at, I have it set up for a NumPy random chi-square algorithm, which is literally, this is all a hops wrapper, which will take your inputs and your outputs and put them over into a hops node. So I'm going to show an example of this, that if I run this script, keep in mind, this script you're looking at is over 6,000 lines. And for somebody that never worked professionally in writing Python, I wrote this 6,000 line app in probably 8 hours. And I wrote it with the assistance of Copilot and by tabbing and entering through it. There's a lot of debugging. There's a lot of little fancy work. And you'll see off here that I'm just simply running a NumPy array with a certain amount of rows and columns, but I have to output my data tree as separate lists. So when I run this script, it's running the entire 6,000 lines of script. And I think we're good here. And in the end, it will output, once it runs through those 6,000 lines fairly quickly, it's taking another second, I hope. Well, there it is. It's running all of the data that's actually shown, which traditionally would come up in a terminal. And it gives me this IP address. Now, that IP address, which I just lost, is going to make callable hundreds of functions. An entire book of NumPy is now available to me through a call IP. And I'm going to demonstrate how to write another function in this little short demo. So I come back over to the hops node and I double click on it. I put in my path. I /, and I call, I gave it a fancy name, NumPy random chi-square. Chi-square. I copy it, I put it in, and now, unlike a GH Python node having to write your inputs, your types, and all that, it's all been wrapped over here in Visual Studio, that it basically just runs a very simple script and outputs by rows, which sadly, unlike working in a terminal, and I had shown this and shared this yesterday, This function will run every time I hook it up, but it's hard coded into 4 rows. So there are limitations on this. But as an architect, you should have limitations. You should know how big the building is. You should know how many rows are going. You can
Yeah.
adjust the column. You can reverse that. Like there's got to be some type of guide. So what I have here is hard coded 4 rows. I can take my columns up to whatever I want. And just with a basic grasshopper, I can have a data frame of a hops integer suggesting where I want that chi-square algorithm to produce a 4 by 3, a 4 by 10 array to give me data to drive something. And if you believe in math and you believe in these algorithms, these point system, once generated, if I run it from a range of 0 to 1, and that's not too exciting, my data frame is going to range between 0 and 1, it's going to output immediately this square matrices. And you're starting to deal in what is normally data trees. Now, the problem I found, because there was nothing online to help with this, there was a little bit of work by Mays. I'm trying to remember his name, and he sent me, like, as soon as you post this stuff, people that are working on it, like McNeil's and other places, or on the forums, are like, "What are you doing?" You'll see that I have to break it into these lists. So there's kind of a loss of using good data trees. And I'm just going to take this, I'm going to take this node that I just made, put in the name, so I know the call to that function. That's pretty cool to bring numpy in. And then I can bring in all my number systems on a good data tree, but here's where it falls apart, like a merge tool. But I demonstrated this yesterday for those roboticists out there. They taught me in Twine is to maintain data structures. I can bring this in, and although it's simple, I can bring in what normally would be a tree. And people are like, well, why wouldn't you just do this in Grasshopper? It's the same thing when you're teaching people who know Rhino, they don't want to go to Grasshopper because they can do it quicker in Rhino. And it's the same reason they don't want to go to Python, because they can do it quicker. But if you start to wrap your head around this, imagine this data, perfect data that I can change the columns and it will update as my tree system. I cannot change the rows. However, if you want to debug, and this is where it gets complex, and I know I talked about a lot of stuff, this is where my passion is kind of live, and I'm going back and forth. You'll see that now it breaks because I only have 4 outputs, but take a look at my terminal. It totally will update. I can go 1,000 by 1,000 square matrices as data if I want to. This little node is running in real time with thousands of other functions. And just let me add one more thing, which I think is really like the mind blown to me, is with GitHub Copilot as an educator, you can usually get that free. This knows with a hashtag, what's the next function I want to write. I'm going to turn it off. And I think if my GitHub is up and running, let me just make sure it's active. It will simply go in and, I'm going to prime it with gamma. There it is. So I'm not going to do gamma. I'm going to say, which one do you want to do? There it is. It wants to do a direct let algorithm. So you get your hand up, so I'll stop because it gets pretty particular here. But this is how fast you can code. If I moved away from coding 25 years ago, 30 years ago, and I'm able to hit tab and enter, take this to an absurd level, which I try to say and encourage people. What if you were a roboticist and you could program a small mechanical arm on your desk to hit tab and enter? And there's your wrapper. I hit enter. There's your name. I hit enter. All I'm doing is hitting tab and enter. And you can see how you can write a 6,000-7,000 line app in a matter of minutes and hours as you go through it. So this will not only write my inputs and outputs, and the reason you want to write this into an app is because it reads what's before it. So if you fixed your lists and your trees and even get into data trees, this will train itself from what you've done. And I've seen this happen again in GPT-4. So it's outputting, it's done with the inputs, and it's just about done. I know this is kind of techy, but I am literally tab and entering through the outputs it wants to give for this algorithm. And the kicker here is it will write the definition and it will write my script, which is simple. And now I'm able to take a basic script, be it numpy, pandas, any other library you want. This is ready to save and run. And that function was just written by Copilot will give me this IP address and I can go in and write it into my Grasshopper scripts. So my Grasshopper scripts are written for you. This is just the section on randomness. And then anything that's in blue is an application of what I'd output. And it's a little disappointing when people get here because my output is this in the Rhino, right? It's like, okay, it's numerical data as points, Michael. How boring. But if you have the data coming in, if you see anybody using gene pool and generating data on a small scale, that is upsizable through pandas, lunchbox, and CSV files, Excel documents. To run a simple script over here in Visual Studio can take what's out there right now, data everywhere, and you're back into that game of data visualization. Hence, a visual artist, the sculptor that used to build buildings in their backyard can start to see the applications of this. I know we're at over the 1 hour mark, but that's the demo that with all the other talk of introduction of what I've done, I have to admit, I am writing these apps whenever I find an interesting book, and I'm going back and forth from the need to import. If I just go here, let me just grab this. This will automatically run through a Hops Flask middleware, and it's only downloading Rhino 3DM. That's all it's doing to run 6,000 lines of code. So Rhino will give you these 4 test scripts, and you'll recognize these nodes because they're point at, they're 4-point surface. You're going to waste a lot of time rebuilding the vanilla tools in Grasshopper. What you're not going to waste your time doing is making the nodes from Lunchbox, but being able to go in them and really have control over them. So this is a way to bypass plugins that you've got the assistants to write it. I know that's a lot of stuff, but I've written this already. I did this in June. There are 6 full scripts, and they each deal with different areas of numpy, and they move into multidimensional. And believe me, when you get into multidimensional arrays, they're all pretty simple, but all of these run. All you have to do is go in and just hit OK and run that script, and you'll start pulling the data from it if this script is running. It will load it. So I've just had fun, not just building these scripts, but loading into them through one node only. Like, this is insane. All the plugins you've been working with, everything you've been doing is sitting here with parallel processing. You can run 10 of these in the same script. You can run them on other people's computers. The complexities here are what really I call falling in not just a rabbit hole, into a rabbit maze. And your choices of where you would go with it. And yes, this is why we're talking, because I'm not a machine learning expert. It's like, what would I do with it? Where could you take this? But I think, like anything, plugins that are too complex or bury too much, just take a look at some of these plugins in Transform. These things are heavy. These morphs are very heavy scripts, but you could simplify those morphs and get access to them by getting into a Python node that simplifies the data you need. So we probably have other questions. I was happy to give that little demo. It literally, if you can load Anaconda, and it's not that hard, sorry, and you can get the hops node running, it's much easier than getting the GHPython remote node going. This is one project that I kind of closed the door on in June, but I'm kind of reopening it as I get into Rhino into Revit. Like, if these tools come in, why can't I build a grade 10 geometry textbook that produces not just illustrations and drawings, but produces landscape architecture, building projects, architectural projects, and for the mathematician and all of us to have those visualizations that you could experience in augmented reality, but experience if you could find the Boss printer to build it in clay in your backyard, you could start having this educational facility. But these tools are available to you just like they're available to anyone. And I think just having somebody, you'll see that this happens in Parametric Camp as well, really good labeling of teaching things. But I'm just running through this. Like, I don't know what's next. Whatever the next chapter in the book is, sometimes I don't even go back to the book. Sometimes I just type in a library search, see a book title, put it in. And because you have to amp up and change everything, I just don't think people can have the copyright on like a list. Like, who owns the list? Like, if you're really just processing a list, what you do with it in Grasshopper, I think, is what becomes unique to you. I think these functions are yours. like these applications. What is your data visualization for it? And of course, NumPy, Pandas, Matplot library is going to make some beautiful bar graphs and circles, but that same data can be driving foundations and curves for, can you imagine just a kaleidoscope type shape that's been taken to offsetting curves through, both sides in Grasshopper? This is going to be miraculous. And it's going to run by not just one sorting algorithm or Python script one-liner. You can change the algorithm just by loading in another title, and you can put it through a stream filter, right? And you could just you could hammer off like 15, just like in an equation tool, you can change your trigonometric polynomials instantaneously in your entire building updates. So that's where I passionately want to go, way back to the points in numerical control. And in a kind of sad way, I see myself being numerically controlled like a machine. Just like a printer knows where to put the clay or the ink, this allows me to have a vision but know how to lay those 3D points. And when I say points, to me, that's not simple enough. You have to drive points by a range of a multi-dimensional array that will control it. So I'm talking way too much, but you can see that I'm off script, and this is
We're
where
really
it ends up going
interested.
daily. Yeah, and I'm looking up here. I'm not even looking at you guys. Okay, so I'm going to stop. I mean, that's a lot, and there was other questions, but you've got to get the boring stuff. I'm trying to get down to my computer, get to my screen. I'm trying to get the boring stuff done, and that's really what slowed me down in Pandas, is all these little technicalities that a lot of machine learners will reach out and say, why are you even doing this in Grasshopper when you could just pull it into Jupyter notebooks and make these diagrams and get to your data? Well, I'm not there to really mudge the data and make it work. I'm there to build a visualization tool that Rhino, hopefully Revit, will be the middle ground, right? People will say, oh, these are the columns, these are the I-beams, this is the weight. I understand it. And not to elude our final questions, if you have Midjourney, if you have Dolly, if you have Stable Diffusion, those matrices are so beautifully standard deviation played out that if you just prompt it with a forest, and say you were a photographer and you wanted to photograph a beautiful scene in the woods, well, it's hard to catch a leaf falling in the foreground, right? But if you're using one of these multidimensional arrays, those outliers of data get interpreted by the computer as those falling leaves. Like if you have a building and you have people population, it will throw in that data. And I've seen people doing this more and more. Very simple geometries. Dusan just did it yesterday, and the people that are positioned are just boxes, just center boxes. Well, it's nothing to put a center box on the points that are driven by these matrices. And the thing is, those matrices are running with what is array vectorized, what's it called? Vectorization. They're just moving at lightning speed. So the trick now is like when to use geometries and slow down your script when you're getting closer, which is why I love Gene Pool, because Gene Pool, you can alter 10%, 1% as you get closer. But what if you could get really close to your ideas, big data, using NumPy? So, you can see where I fall short on the machine learning questions, but it's there. You start to see it in your head. And recently I've been taking E to that rotation that 3 blue, 1 brown does, to matrix rotation, complex numbers in 3 dimensions. Like this is crazy. So anyway, you got to kind of dream. Sorry, I was ranting, and that's kind of when I get going.
We're really interested, and this is really entertaining. Thanks a lot for showing us. We'll try to go faster in the upcoming
Yeah.
questions. Yeah, and
Yeah, we don't have to cover all at the end. So how do I exchange? I think we went back on slides. Yeah, and I don't have my, I probably answered that. So I'll just answer off the cuff. How do I engage students in my online courses?
yeah.
Well, I do what they do with a lot of those other projects online is I will send them out back into whatever they're good at doing, back into their painting. Like usually a painting student will be inspired by a landscape that they took on a trip and took photographs. So a lot of times with computational design, they simply have to get out and make some new discoveries to what they weren't seeing. You have to slow them down, and then you've got to build these relationships. And I think teaching them Rhino very quickly and showing them how to move and iterate and have a user interface, but then show them that computational control that comes with Grasshopper. And I do not expect students to write their first scripts. I hand them dozen to 2 dozen node scripts that work. They modify. It's like anybody, because I have 3 kids. They don't make a game. They take a game and they modify that. So that's really helped, is giving them something up and running and then letting them see behind the scenes, and then they'll show me something totally new. That's kind of how I do that. I engage them by giving them an awful lot.
Yeah. Okay, great. Would you like to share? Yeah, we shared already this project with earlier.
Yeah,
Yeah,
I think that's good. Yeah, because that's what I was doing back in June. But the ones now we can kind of talk about. What do we have here? Yeah, this is what I'm working on. The GPT-4 text prompts are amazing. I actually lost my script, and a fellow wanted it. I posted the wrong one. I went back to the transcript and just downloaded the script and put it into a GH node on a blank Grasshopper document. It's that fast, like GPT-4. But you have to teach it like a child talking to a child, because it will do everything you don't want it to do first. So it's very tricky to get into, but I've found some really key prompts that work. Just as simple as don't do anything in the Rhino environment. Make sure it's all going into parametrically the GH node in Grasshopper. I've also found out how to make things parametric from the scripts. Don't make them parametric with GPT-4. Do them there. And I'm writing a physics app from Richard Feynman's notes, because he did these beautiful notes and diagrams. So I'm like, why can't I just write those in the Grasshopper? I talked about pandas. Machine learning is coming after that, but it's returning what I was doing with the one-liners. So it's all been written. And that's where I've gone back to GH Python remote right there. I've actually put that one back in, because now I'm able to delve where I was. Now, I'm not looking at my presentation. I was kind of reading through that last slide. So just give me a second. What were some of the other projects? I just opened Fusion accidentally. And I just made your screen too big. Yeah, so the Hypar reached out and building assets for Revit. So absolutely August 1st. I know we just entered that month. I am going so hard and fast into looking back into my Archistar Academy and making sure I can run things, getting my Dynamo running, because knowing how to work in Grasshopper after 4 years and coming back to Dynamo, it is going to be incredibly smooth transition. And of course, I'm not looking to build some very traditional buildings. I'm looking to build some very conceptually algorithmic building, yeah, like math buildings, like visualizations. The other thing I'm doing is the RS means illustrative construction dictionary is my prompt. I just open that book and see an illustration I like, and I take my prompts and tailor it to it. And I won't go above 100 lines of code. I wait till the code hits 100 lines, and I'm happy with what I got. And an A-frame house might have some boards. It might have a parametric door. Are we okay? Oh, something just popped up. And then the GPT prompts, I've realized they can really run Rhino Common quicker, but NumPy runs slower. There's always a trade-off, because the developers have not found these plugins for us yet. So I think somebody has to be out there reaching and grasping, saying, wouldn't this be nice if it did this? So if you can get some basic things going. So I'm really going back and forth from hops to GPT-4 and then Rhino Python. And it really depends on the project, because just like machine learning, I've read enough. There's no one algorithm that's going to solve your problem. There's no one way. And so I'm looking for a team of machine learners that can tolerate my chaos. And we do some of these Kaggle competitions, because I can provide some visualization, creative visualization that might tip the scales on who's awarded in some of those things. A nice example is downloading the data on the Titanic sinking and building an algorithm of where things are in the ship according to class and gender, and who passes away and who doesn't. That's a simple visualization tool that, with some boat plugins, you can make a pretty awesome graphic that somebody's just going to be looking up bar charts in NumPy. And I think you have a chance of being acknowledged for that.
sure.
So take what you can do well and do it together. Okay, I'll keep going. Sorry. Yeah, GH Python remote. That's beautiful. Yeah. Well, you'll probably edit the video. We can shrink that first part and when I ramble.
Exactly. Okay,
No,
so
yeah. So
we
that's
want to
one
talk
that.
a little about Wickerson Studios, its courses, the script bundles that you offer to the people.
Oh yeah. Let me pull up that PowerPoint. I had it. I just keep open. PowerPoint and Fusion have the same colored icon, and I just keep opening Fusion. Uh, it's usually juggling. That's how I kind of go. And my time is running out, right? I've got a week to plan my classes for the fall. So it's like, it's always tight to do this. So if I just take a look at where we were, recent projects, the Hyper project, I can't even get started in until I feel confident, but it's all user interface. I think any job you get is going to expect you from the softwares you've said you know to transition to their software in like 2 weeks, right? And they'll let you kind of fail, but you've got to do this. I did have the very simple illustrations happening on the RM means illustrated construction dictionary, but not only creating objects, don't make nouns. Like, don't, like, this may seem strange, but why would you script in Grasshopper a noun when you really want to script scraping algorithm, right? You want to build this that you can actually do molding and plaster, or you can make a template. Like, and this is where I thought at the beginning of the year, beginning of the summer, by fall, we'd be text prompting our 3D models in art school. We wouldn't need a mouse and keyboard. And I said, how's it going to come? And I put my bets on complex trigonometric polynomials. I said, if we can, it's like going nerds. It's going from points to inference lines and surfaces. And then there was this other school that was like, let's do point clusters and let's like make this come about as a mesh. I've never been a mesh person. I think mesh can be solved from what you make modeling. There's going to be a lot of cheats this fall with the plastic wrap. So we're going to have students that can't make a good model and they're just going to wrap it into this 2 million mesh. But I think if you appreciate it's coming from math, if it's coming from, so whenever I build a curve in Grasshopper docs, I don't have 3DM files. It might be odd to say, but there are no 3DM files on my computer. Everything, if there's any objects, they've been internalized into those container nodes, but I even tried to avoid that for the most part. The people I wanted to reach out to is Christoph Voislav from BIM Corner, my Abdel Salam Suleiman, who's doing tons of work, digital futures and working in GH Python. These giants, Gediminas, and they all know each other. And Timo Zollner, like, I'll be sad if I don't get a strange email once a week saying, of course you're doing something crazy like this. Peter Davis was a fellow that inspired me off the bat, that just absolutely moved between different companies and understood. He really pointed out to me that if you had a simple algorithm that could understand the numbers pushing points and vector fields, you could do anything from prosthetics, medical professions. And then on your use, Goon, who's down, came through MIT and he's down in Turkey. I've watched what he's done for a long time. He really is a promoter conceptually coming at things. And then Mahmoud Ramdan, I followed, and he was getting his undergraduate at the time or his doctorate, and now he's set up in Morocco. Like, in Junichiro Horikawa, he's moved from given all of his GH files online, but now he's moved into Unity, he's moved into Houdini. Carl Singlein's robotics are incredible, and Jose Luis Garcia. There's tons. These are just like 10 that were the first 10 picks that I'd been kind of trying to get in contact with and watch videos, but incredible people. And then I guess I came across this line, like, do something for 1,000 hours. And it's just like, if I want to pick up the banjo or the guitar again, I've got to sit and I've got to practice that every day. So you really just have to get in here. And I have that Richard Feynman quote that there's no miracle, people, because he says, I was just an average person that studied hard and worked hard. And I think I'm in a school that I have to encourage that from day one, because you're coming in with this possibilities before you, but it's not going to be gained. Like, I knew if I did 4 to 5 years, I'd still need 8 or 12 in a software to really shine. And that's if I focused. Being curious will make you go down so many paths. And that's really where I ended with. And then there's a few digital prompts I put up. And then sincere thanks to Abdurrahman
This
Fahmy for putting this together. And we had a little snags, but we didn't know I was going to rip off on that example. And, you know, we could have just done that.
I will show this important video that you sent me.
Oh, it's beautiful, and
Yeah,
it's just wonderful. I wish somebody showed me that when I was in math, and I didn't know where I was going, because I went into printmaking and sculpture. I could have chosen architecture and engineering, but pure math and computers was so divided in 2090 at Waterloo. Like, you would be in your algebra calc classes, take physics, biology as your electives, and your computer science class would be completely on paper. You'd have one tutorial in front of a computer, maybe 10 minutes, an hour a week, but there was no hands-on. There's such a distinction. But I think the teachers, the mathematicians, and computer scientists realized we need to get together. And if one thing from this lecture is, artists cannot survive on their big commissions if they don't have an architect working on their airport commission with them. And now I would argue they need their developers and their programmers and engineers to get anything done. So I've come at it both ways. I used to think business made an artist good, and art and businesses used to get better if they dealt in the arts. But now I realize that camaraderie and getting together is going to make things happen. Anyway, I'm rambling like I normally do,
Really
but I'm
good.
not anxious when I
You're
ramble.
doing great,
I,
really.
I think I make other people anxious when I ramble. Um, yeah, and
So,
and I do balance 3 kids and a wife, Beth, who's amazing, and they tolerate me on a Saturday and being here. But you really just have to pick your time when you can sleep. It's tricky,
yeah,
and you got to get to the
architects,
gym.
architects don't
Yeah,
sleep, I know.
yeah, I know. I remember that from undergrad. They were like for even harmful to their health. I remember that. That is a school that if I say physics is a tough degree and philosophy is supposed to be really hard if you because every doctorate is this doctor of philosophy, but it was the architects that put in the most hours because they have to know everything about art history, they have to know everything about the mechanisms, they have to know the math behind it. I think that was one of the most, but it did the most progress at the University of Waterloo in ceramics. It wasn't coming out of the ceramics building dealing in craft. It was those printers and things they're doing at Waterloo. I'd rather go back there and see what's going on in those programs. Huh. Now my old faculty is going to be mad at me. All right.
We want to thank you for your time. Uh,
Thank you, everybody.
this was really great, and we're really
I
grateful
broke a
for your
sweat.
time. Yeah, we're
Well,
really
I'm always jumping online. I hope we work together in the future. I hope we share ideas, and I really thank you. And I want to also say you've been so kind through this process, and I've received such a generosity from you and politeness that it's so uncommon to me. Like I mean, like on this level, and the details of what you did. It was just so strange that with all our preparation, we hit a little snag with
yeah,
sound.
we're
But
prepared
you
for
have
this
done
a lot.
an exceptional job and made me feel so confident in this. Thank you so much.
Thanks a lot for your time, and
No worries.
we'll arrange something again soon, hopefully with a better arrangement. Yeah, maybe
Yeah.
after you
No,
finish your Revit and Dynamo
I
work.
think I'm going to have something there, and I also thank you for encouraging me to put a PowerPoint presentation together because just like 3DM files as a teacher, I just go live at the front of the class. There's so many directions that students can take. I'm not one into these PowerPoints, but it's so good to make one. So I'm going to be using it as I go back to classes. Thanks again, and thanks everybody for watching.
Thank you.
Yeah, I could come or go or answer questions, but I think I'm done.
So give me
It's up
a
to
minute
you.
to see if anyone have any
Sure.
questions, please.
Yeah, I don't see who's there or chat or even if
Yeah,
we have an audience, but I think we record this and share it. It'll be great.
yeah. People are saying they're enjoying the interview and they don't want you to go.
There's so many questions. And honestly, the only thing that drives me away is obviously life. And Richard Feynman's another one. He has a beautiful quote in there that's be passionate about the thing that you want to do. And he does say, like, just do enough of normal life so it doesn't take away those times
These
for
things
you
are
to be doing
heavy.
what you really
These
love to do. It would be great if they synced up perfectly, but I think innovation and those ideas, you just have to trust your gut. And I think when you get to be 50, you kind of, if you can get past this sharing online, and COVID really pushed us into it, I have nothing to lose, and I don't mind appearing a fool on one video or it doesn't work on my live feeds somewhere else. Um, just be persistent. And the best thing is, you might think you'll get trolled or something negative. Well, you'll get that kind of on Discord and forums the odd time. I have never received a, I'll probably get one now that I say it. I have never received a bad comment because the complexities and intensity of what you're looking at, people just don't look. But the ones that take the time to look, the few dozen out there in the world, they're always going to be kind and insightful. And whereas I had some real hard criticism last week on this isn't machine learning, this is applying AI apps to solve this. In the end, it was a younger person coming out, I think out of Cairo. They said, if you need any help, because I showed evidence of what I'd done with NumPy and pandas and tried that even if you're failing or making the wrong statements and you're willing to backtrack and correct that, people will go out of their way to help you. I learned that with digital. It's easier to say yes than to say no. To refuse these technologies, you're always defending it. But if you just say yes, people will come out and try and solve your problems. And with now, you've got GPT trying to solve your problems. I'm very polite to it.
This is
And I'm so polite to this program because I don't want to upset it. I don't want it to take my license away. So anyway, thanks. That's kind of rambling like a
thanks.
teacher,
We
but
love it.
it,
Okay. Thanks a lot for your
I you wish everybody would be interested in what you're interested in, but sometimes you're dealing in the new and it's unrecognizable for yourself and others. You can't expect them to even see it. So I know I've done that twice in 24 hours with you, but I always feel like I'm talking another language sometimes if I look up, certainly to undergrads in visual arts. I can't go hard into that. But you have to get them hooked somewhere. They have to see the connections.
that's
And yeah, definitely biomimicry and drawing. Anybody who drew and gains the skills to draw with these mediums or conceive with these mediums, once you can make your visions, be it audio, music, anything, or architecture, once you have the tools that can make that a reality for others, it's hard to stop, right? So
that's
it
true.
gets to be a real passion, not a hobby, but a real passion. Anyway, that was a blast. That was the best interview I've ever done. And well, received and enjoyed and got in there and did a demo. That was
Yeah,
fun.
and hopefully your voice was absolutely clear. Hopefully, yes. And this
Good, good. Well,
was
yours was
very
fine. It was a little it was a little consonants were hitting more than vowels or and I'm trying to learn. You might see I made a script that doesn't work teaching Arabic and Grasshopper. I thought that would be fun, but it doesn't treat the words the way I'm supposed to run them
cool.
together. So, but I'm trying to adjust my eyes to seeing Arabic the same way that I adjusted them to seeing Cyrillic. And it was easier to do in Latin, but when I was in Bulgaria, I had to read signs that were completely different languages, but certainly in the same direction that I was used to reading. So, but it's interesting to think that Rhino can start to do these things for you. GPT-4 is trying, but it's
Yeah,
not very good at it. Anyway,
thank you so much.
uh,
We're really
yeah, I
grateful.
think that's it. My last comment is coding is probably the most shared common language. And it may not be our first languages, but if we could meet up there a little bit, that'd be awesome.
Yeah, that's what I was trying to do with this interview because I wanted people to be encouraged, more encouraged to think that coding is not really that hard. That if you learn a language, maybe personally I'm biased to C sharp actually. So if you learn somehow hard language, then everything else will be easy. You can just transit from C sharp to Python, and you
Yeah,
can go from Rhino to 3D Max to AutoCAD to whatever
yeah.
software you.
Absolutely.
Yeah,
And people are already doing it. People don't realize in Rhino, they can simply, in the command line, cut and paste those 500 memorized lines
yeah,
and put them into another Rhino document and it runs the script. You're already coding. But there are people that don't even want to look at the command line. They look at the icons, they
yeah.
look at the environment. They don't want to look in that direction. But you're already, if you just glance up there, it's showing you what it's doing. And what's nice is to customize a script or modify it that you can interject your name, your computer, you can make macros. They teach that in the certification too in Rhino, like right off the bat. And I've done it, but I haven't paid the $90 to test on it yet. I should do that. But it's like you are coding, and it is just like Dynamo is advertising itself. It says right in the Revit toolbar, visual scripting. Like it's just I'm a little upset today with 2024 Revit. It's taking almost 20 minutes to load Dynamo, and I saw there was a bug online. I have to wait for Dynamo to load up. I blame my computer systems.
Just
I work
download,
off of a.
right? Not to download anything.
I want to say one more thing because I always like to. When my computer broke, I took my kid's Kano computer, which he built as a Raspberry Pi, and I made that Python app for NumPy on that Raspberry Pi. So what this proved to me is with what might be 100 or less American dollars as a computer software, it pushed me to think in Linux. It made me think in freer operating systems. And you realize that this lightweight operating system or programs, if you get into that programming, that's accessible to you anywhere. And we're talking with like solar power. You could carry it around in your truck and you could have that Raspberry Pi. You could go live from that. So that was really empowering for me is to realize I didn't need the school's equipment. I didn't need that big $3,000 computer. Just a little cheap Kano flip top is enough as long as you keep all those Revit files are huge. Every time I save them, they're 40,000
That's
kilobytes. I'm like, what? So I'm a little upset that my computer is going to slow down. Um, for that. But if you don't have a big budget, you can go as deep intellectually on these and outputs as anybody. You don't. It's not dependent on the cost of your equipment. It's amazing, and so I think that's just fantastic.
That's true.
Right. I think we're good. I think we're at 12:30, and I think we had an hour-long talk there in there, and hopefully the audio's fine. And I really
Yeah,
appreciate it. Hopefully we can be in touch again. I know some of the people you know, and they've all come through the American University in Cairo, and I hope they get a glance at this video because
yeah. So
it
if
really
Ahmed
is a
Hassan
blast.
is watching this live, Ahmed Hassan,
He was beautiful. I have to mention because he said, "Mike, we're bringing you in here after me, Rhino, and Sujay Kumari Robotics. I want you to know why we're bringing you here. It's because you don't do things the way anybody would come do it and think to do it." I remember this, and it was like so encouraging. And there was other people online that I know. I should have mentioned Pier Nicola Mussolino. They found me at an early stage and said, just send in to this private group, Fans Grasshopper. And they saw this curiosity and not being trained. And I think that's why I've been allowed in Zaner companies and Dimensional Innovations as somebody curious, because I will ask questions that their engineers and architects know are impossible. Like that's why you get pulled into those areas and you get put on a team of architects for a commission. So I think that really does help. And I really want to reach out and just say thanks to Ahmed because he's been fantastic. And I think I'm still consulting on something, but he's always up to something
yeah,
major. He had a great thing at Digital Futures. I know that. I was watching that.
yeah. And on the personal side, he's really, really good and kind person. Yeah,
I learned
he
he was
helped.
in Australia, so I shouldn't be telling all this stuff. But the internet's amazing.
Yeah,
As long as you're willing to get up in the middle of the night and talk to people in different areas of the world,
that's
uh, and you have the time for it. So I don't know if I could have done this in my 20s. I would have had to get the job. I would have had to do all the casting. I would have had to do all what I was hired to do. But now I have this liberty to. I think any professor, as they get older, wants to have research and wants to mentor at a graduate level and help people, but they want to do the research. So that's where I'm entering in this next decade, I think. And who knows what'll happen? There'll be new softwares. There'll be
that's.
something.
But you learn coding, so there's no uh,
Yeah,
fear of any new software.
yeah. It's a language, and even though you can't read maybe the most complex poetry being written in that language, you can read the language, and so you might not understand everything that's happening. But I absolutely think coding should not be taught as a studio class. I think it should be taught as a liberal arts language course. I actually think it should be credit for hour instead of like 2 credit hours. I've talked things like this. It's not a studio based class unless you make it all fabrication and manufacturing. But if you do that, the scripts get very simple, and the what is it called, troubleshooting goes to the machines, and you're lost in this engineering of things, which can be very frustrating for somebody that's trying to explore a new idea because it just doesn't print. It just
That's
doesn't come out at the right speed.
yeah.
I saw that. Anyway, I should probably let you guys go. I know I'm holding you here, but
Thanks a
I'm
lot, and
excited.
we're waiting you in Egypt. We hope you visit us soon.
I I I've got a couple more years till those kids get a little older than 6, but I would like to come. I'm between 14 and 6-year-olds right now, entering high school next year, and late having kids. This is if I had done it at the right time, they'd be 20, 22. They'd be off at their schools, and I'd be visiting those schools. So
Best
I did
wishes.
things backwards a bit. Yeah.
Yeah.
All right. But thank you for the invitation. I definitely have taken up people up on their invitations. Pretty good at imposing to a certain level if it's an invite. Thank you so much for letting me share this research because it's so hard to get people involved. If people want to go to the GitHub, I did have that open. All those files I made private again. I moved them over into wickersonstudios.com. Contact me if you want access to them. And I don't mind saying if somebody asks for those repos or wants to give me their GitHub and they don't have the money or there's parity, my prices fluctuate. The only reason I price them is to find on PayHip who's interested in what. But I will definitely send you a pretty awesome discount up to 100%. So, like this is how I've been distributing my work because I'm able to see people and meet people. GitHub open source, you don't know who's looking, who's grabbing it, if they even have an account. But I've enjoyed that lately and it's bounced up and down. So that's available to you. And there's over 100 repos in there. And I've even been digging in the old works. But it would be great to have some people that want to work on the pandas, Pops. And I know you just started looking into it. the files that I sent you yesterday. So I think that machine learning is waiting for us to apply. That would be a blast. And hopefully I'll have enough knowledge to bring it into Revit. So anybody can jump in on this research. That's what it should be. I'm just not going to be the one that tries to produce a very clean, marketable plugin. I'd like to do one that's open source. But right now, we all have to wrap our heads around Grasshopper 2.0, which I've made plenty of repos on. Every time I load it, it has to reload because it gets its updates. But if you loved math and statistics, you're going to love Grasshopper 2.0. It is absolutely insane. The graph mapper in Grasshopper is like a kid's toy in Grasshopper compared to the function editors that are in Grasshopper 2.0. And so I do have a few files out there that are available too. And I'll just send you 5 years worth of research if you want to even have it. And it's not heavy on your computer, right? Like it's
That's right.
not that
Yeah.
heavy. It's
Everything
incredibly
works
light.
really smoothly. Yeah.
Yeah, it's GH files and it's PI apps. And so they're like kilobytes. They're
That's true.
ridiculous. There's a couple of big ones, but those are when you use image samplers. Anyway, I'm rambling again, but I've got an audience. I got somebody interested. So one thing I tell my students is if they look at me, I'll keep talking. So this is kind of how I go,
Yeah.
or until my wife yells at
Looking at
me.
All right. Thank
But
you, everyone. We're really glad and we hope that you learned from Associate Professor Michael's experience.
yeah,
I myself enjoyed this really, really very much. And I want to thank you for opening a lot of possibilities for me to research after maybe I finish my recent project. But yeah, I find a lot of what you do interesting, and I'm willing to start exploring with a lot of plugins and with your repos that you sent me as a gift. And I want to thank you for that. Yeah,
sorry. You share them with whoever you want. If somebody takes an interest, I think it's too much to unload onto somebody because they're like, how do I open GH Python remote? How do I open hops? How do I get Anaconda? It's best if I put them in like basic, intermediate, and you'll see all the files. What's strange is people really gravitate to the files that do a lot for you. And I'm just going to take a peek over the Facebook for a second. Oh, it's I think I'm in good shape. It's just a little quick message from my wife, and it was the little heart. So I think I'm in good shape.
perfect.
No, if anybody wants to reach out and work on these things, like this encouragement goes so far. It's like getting a note from a student or from a student's parents. You wait for that because it's like, okay, you did something that helped somebody. And I could make them all open source, but who would engage? Who would call me? Who would actually ask a question about them? The video tutorials, you end up spoon feeding everybody and making the videos so people copy it, but nothing learned,
Yeah,
right? Like if you're just doing that and you didn't even modify it. So when I'm learning from this fellow I mentioned, Walter Zesk has these beautiful things, or if you go into Unichiro Horikawa's GH files, don't look around for those import curves that they made. Don't go into that. Make your own curves and make your own curves from another script that you had from somebody else. When you, it's like reading books. If you had 5, 6 philosophy texts you're reading from different continents, different times, that synthesis of what you do, and I would call it the Socratic method because I'm used to that in school. You analyze it, you come up with new ideas that they could never have had. Like I can have a conversation with Socrates, but they can't have a conversation with me. So I can start bringing those minds together, and that's where I think we really do help each other and knowing what's of interest. I wish I could do it full time for the next 10 years. That's really what I wish, and I've tried to bring it into my art school as best I can, but you know, time is time, and you have to have life, and life is great. So, and I also have children growing up into this world, so why wouldn't I want to know about the tools that are available to them? I have a responsibility to that. I can't like this fellow today that said, you know, let's save that for the youth to do. You better know as much as you can about it, you know, because
true.
it's going to change quicker than you. Anyway, that's it. Keeps me young, hanging around young people, and asking these questions, pondering questions, being curious. That's it.
Thank you, everyone. We're going to
All right, I think we're
slide.
good.
Thanks a lot. And yes, now like over. Yes, yeah. It's just yeah, just this.